Oh, a question may be thrown on this particular fundamental also. Now let us talk about Taylor's theorem. This is not the tailor who stitches your clothes. The name of a scientist, basically. Taylor's theorem. So, what as Taylor said was that I'll talk about the statement first. Taylor said that if a function fx is such that case 1 fx and its first n minus 1th derivatives are continuous in the closed interval a comma a plus h. Now h is again a very small, infinitely small point. Wherever we are denoting h in calculus, always understand that that is the same h is a small, infinitely small point or a size which is tending towards 0, right? And second part he is saying is that f nx exists for every value of x in close interval a comma a plus h, then there exist at least one theta, you can say, where theta is between 0 and 1, such that f of a plus h is equals to f of a plus h times of f dash a plus h square by 2 factorial times of f double dash of a, and so on. We'll go on till h raised to n upon n factorial and upon f raised to n upon a plus theta h. So this is basically the crude form of Taylor expansion. You can also have a modified form. What is the modified form of Taylor expansion? If I say x is nothing but a plus h, right? So what will be a? A will become x minus h, or h will become what? X minus a. So if you want to find the modified form, you can say the modified form of Taylor expansion. The modified form of Taylor's expansion is f of x is equals to f of a plus h is x minus a times f dash of a plus x minus a square by 2 factorial times f double dash of a, and so on. This is the modified versions of Taylor expansion, right? Now what happened with this thing is Taylor gives this expansion for any function, right? He said that about a point a you can find out the expansion of any function in this particular fashion. But there was a scientist called as Maclaurin. What Maclaurin observed was, Maclaurin said ki no boss, this is not true. What Taylor have assumed is he has taken that all the values which is taking is along a point a on the plane, because he's doing it along the point a. So for some functions it is correct, his observation is correct, right? But it is not a universal fact. He said it is not true for all the functions. So what Maclaurin said, and he named it as his own formula, and he called it Maclaurin series. Maclaurin series, or the Maclaurin formula, famously called as. What he said was, if you do the Taylor expansion across a point 0, that means across origin, then you will get the values or the expansion for each and every function in this universe, right? So what he said was, let us say he do it, what he's trying to do it, he's saying that in Taylor series, in Taylor series, or the Taylor's expansion, or Taylor's expansion, take a is equals to 0. He's taking it across point 0. Then f of x will become f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 plus x cube by 3 factorial f triple dash of 0, and so on. So this is basically known as Maclaurin's series or Maclaurin's theorem. Clear? So this is how it works in the Maclaurin case, right? This is how fundamentals can be tested. Now similarly, you can also check it out, for example, if I say you want the expansion of fx is equals to cos x about point x equal to 0, you say it's expand fx equal to cos x about point x equal to 0. Now we can use Maclaurin theorem here. So fx according to Maclaurin is nothing but f of 0 plus x times of f dash of 0 plus x square by 2 factorial times of f double dash of 0, and so on. So let us first find out the values of these. What is f of 0? F of 0 would be cos of 0, which is 1. What is f dash of 0? Which will be nothing but sine 0, and that will be 0. What is f double dash of 0? It will be nothing but sine derivative. What is the derivative of cos? It will be minus sine, sorry, not minus sine. It will be minus cos 0, which will be minus 1. F triple dash 0 will be minus sine 0, which is 0. F fourth derivative of 0 will become cos 0, positive, that will be 1, and so, right? So we substitute this thing. So fx will become what? f0, that is 1, plus x times f dash 0, that is 0, plus x square by 2 factorial time f double dash x, that is minus 1, plus x cube by 3 factorial time f triple dash, that is 0, plus x power 4 by 4 factorial into f fourth derivative, and so on. So if you see, this will shortlist to 1, plus this term will become 0. So this is not plus, in fact you will be getting this to be minus x square by 2 factorial. This term again will become 0. So this is plus, so this is fourth derivative is positive, so you will say x raised to 4 by 4 factorial minus, it should be x raised to 6 by 6 factorial, and so on. And we know also that the standard expansion of cos x is this only. We have studied in our earlier standards also. So that is the answer. Clear how to basically solve this particular type of question, right? Let us take an example on this so we'll understand it much better. Let's say, let us take a GATE question which came in GATE 2008. In the Taylor series expansion of e raised to x about x equal to 2, the coefficient of x minus 2 raised to 4 is 1 by 4 factorial, 2 raised to 4 by 4 factorial, e square by 4 factorial, or e raised to 4 by 4 factorial. So Taylor series expansion of e raised to x will look like f of 2 plus x minus 2 into f dash of 2 plus x minus 2 the whole square by 2 factorial into f double dash of 2 plus, so there will be a term which will be x minus 4 to the power 4, sorry, x minus 2 raised to 4 by 4 factorial into fourth derivative of 2, isn't it? So actually you are looking forward for the coefficient of this term. That means you are basically looking forward for this term, whatever this is going to go, isn't it? Right. So if you solve this, fx is e raised to x, so f of 2 will be e raised to 2, and fourth derivative of this also is going to be e raised to 2 only, isn't it? Because e to the power x derivative e to the power x. So therefore the coefficient of x minus 2 raised to 4 is equal to e raised to 2 divided by 4 factorial. This is going to be e raised to 2 and this is going to be 4 factorial. So that's your answer. That's option number